Hello and welcome to this Innova Systems webinar with me, Adam Rose. In this video we're going to have a look at cams and grooves within SolidWorks. These two tools are contained within the toolbox and they're tools that can slightly automate the process for the creation of cams and for the creation of cuts, revolve cuts for the grooves for retaining rings and O-rings. Okay. Now, they're fairly simplistic tools, but they do sort of help your design process along a little bit. What I'm going to do first of all is have a look at the grooves tool. So I'm going to switch over and open up a recent document. Now this assembly file, I want to put on a retaining ring on this end face in order to hold this mechanism in place. So what I'm going to do is to open up this part, because you have to open up the part in order to insert the cuts for the retaining rings. You can't do it at assembly level, for example, by editing the component. So we've got to make sure it's open in its own window. I've just coloured this end face here so I can tell which face needs the item applying to it. And what I'm going to do is I'm going to open up, first of all, and make sure the toolbox is turned on. And we can do that from the add-ins menu. Just make sure toolbox and toolbox browser is enabled. Okay, that just means that later on we can go in and we can actually turn all this system on. Okay. So what I'm going to do is open up the grooves tool from the menu. The grooves tool, within here we've got O-ring grooves and we've got retaining ring grooves, and you'll see we've got some quite nice sort of illustrations for which one's which. And if you switch between your different types, it'll allow you to just get a preview of the difference between them if you're not quite sure. We can switch between here on the standard to choose different types of standard to work within, and then we can also choose, like say, the different retaining rings. I'm going to go for a C ring first of all, and it really is as simple as just selecting a face in order to insert this item. Now I'm selecting near this end of the face to insert it. That will insert it around this position. You'll see that my selected diameter gets inserted with the groove diameter selected automatically for me, so it's chosen the sizes from this section on the left here. And if at this point I choose to turn to maybe the basic external retaining ring, it automatically sizes that item up to the right size as well. So it will size when you're switching between. What I can do then is just click the Create button, and what that does is it just creates the item on that face. Really quickly we just end up with the profile there, and then we can just click the Done button, and that actually is all we need to do to actually insert the grooves for this section. However, we've not actually inserted any dimensions as to how far along the shaft this item is actually going to be inserted. So if I switch back to the assembly and just rebuild now, you'll see that we've got the dimension from the end there. If I just control select the two faces at 2.55. Okay. Now that dimension we need to make sure lines up with what I've inserted just here. So if I switch back, I'm going to edit the sketch, because this is actually the second process you need to do after inserting a groove. I'm going to go ahead and first of all just give it some kind of relative position for the rest of the assembly, so just fully define that in position. And then what I'm going to do is to go ahead and just put in a simple dimension which controls the position of this object from the end there. And that's just going to be at 2.25. Then rather than actually going through and dimensioning up this whole object, I'm just going to right click and use the fully defined sketch tool. If you haven't used this tool before, it's a very quick and easy way of going through and fully defining your sketches without having to do it all manually. It will insert relations and dimensions, and you can insert them from a baseline. So the baseline for horizontal at the moment is this line down the center. I'm going to switch that to the line just here on the groove cut. And then we've also got the baseline for vertical dimensions just here. I'm going to insert the dimensions above the sketch and to the right of the sketch. And then all we do is click the Calculate button. Okay? It will automatically insert the dimensions for us at that position. When we're happy with what we've got, we just hit the tick, and then we can just drag the dimensions down and into place. And if we just zoom back in now, you'll see that that's nicely inserted those items on top of my sketch. Okay? We've got a nice sort of idea of what we're getting there. Okay, so that's fully defined the sketch for us, you'll see in the bottom right hand corner. If I just rotate around switch myself back into the assembly model. I'll just close down this design. You'll see that the retaining ring groove has been cut into the design, and then we can go ahead and actually insert the retaining ring itself. So we tend to go into the toolbox, browse into the particular standard we're looking for, select retaining rings from the menu. I'll go for external, and then we can choose that basic retaining ring. And I'll just zoom in on this face and then just drag the item physically into position. And we get a little preview in the graphics area, and if we drop the item at that place, you'll see that it auto sizes, like any toolbox items do, into the groove we've just cut. Okay, then we've just got to escape out of the command and place that second mate just to hold this item in position. So that would just be a case of mating between this face on the back of the design on the cut there, and if I just right click and select other, I can select through the model and just select this face to pull the two faces together. Okay, so that's as simple as it needs to be, the process for actually creating and inserting a retaining ring onto a simple model like this one. If I'm going to go for a bit more of a complex assembly, I'll open up and we can have a look at the O-rings setup. Okay, here we go. Here's an assembly. It's got some pieces underneath which I'm going to actually insert the O-rings into. To see through the model, I've actually set up display states which I can switch between. This one's the one I'm going to use, and it just gives me a good idea of what's inside the model there. So I can zoom in on this section and I can actually insert retaining ring grooves and O-ring grooves around here. All I do is just open up the individual parts by clicking, and then we can insert maybe a retaining ring groove at this top section. So we go to the grooves menu, select maybe basic external. It's the same process. When we select a face to select the diameter, it will insert the item, if we choose internal, at a slightly larger diameter than what we've selected rather than slightly smaller. Okay, that's all it's doing, and then we just click the create button and it just creates the groove at the position we've clicked. Okay, and then obviously we go through that process we just did of fully defining and getting in position. Okay, so that inserts that one. To insert the O-ring grooves, or we just open up an individual part from the same menu. We can go to Toolbox and Grooves, and you'll see now we've got the ability to go ahead and put in O-ring grooves. And again, it's set up by different standards, and then we've got different types again with some quite nice illustrations just to show you the difference between them. The selected diameter, well, I'm going to go for this face just here. And I'll just click the create button on that face and it will just insert it at that position wherever I've clicked, and then it just needs a few dimensions in there. I won't fully define this sketch, but I'll just place one or two just to get it roughly in the right place. So those two relationships should be enough just to hold it in position. And if I switch back to the assembly model now, you'll see that that's actually what we've inserted. And having looked through the design on a section view, we should be able to see just through that part of the model. Okay, there's our retaining ring cut, and there's our O-ring groove there on that section. Okay, so it really is as simple as that to actually insert the items, and it does sort of speed up the process if you have got a lot of those to actually insert. Okay. The next section and area I'm going to look at within this webinar is the CAMS tool. And if we open up a blank document, because currently we can't access that toolbox menu. Now on the toolbox menu, you'll see we've got a CAMS menu up here. Okay, the creation of CAMS, again, is fairly straightforward. We've got either the setup of linear or circular cams within here. We can create both, and I will show you how to do both within this webinar. We can select from units. We can choose how the follower, this section just here, is actually moving in relation to the cam, whether it's offset to the right or left, or whether it's swinging. Okay, I'm going to keep it fairly simple, put it to translating. The follower diameter, that will be the size of the actual head, and then we've got the starting radius, which would be the distance from the center of my cam to the center of the follower head. Okay, so whatever measurements we put in here, it's not the actual size of the cam face, it's actually to the center of the object. So if I put in 3 here, the actual size of the edge of my cam will be 2.5. Okay, obviously half of the follower diameter minus the radius value. And the starting angle, well, that's the starting position basically, and I'll put that at 0, and then we'll move around to 360 degrees. So when I'm actually creating this item, if I just switch back to my PowerPoint for a second, we can have a look at the different types of cam, because we've got lots of different types of movement we can select from when we're actually creating the motion for these items. And that's actually available on the Motion tab. So we click the Add button, and you'll see there's all these different types we can select from. If you do need to sort of reference and find out what all of those are, I've done them very simply, just illustrations of the different types of the cam and what they would actually create on a very simplistic dwell cam. Okay, so we've got 120 degrees of dwell around that first section, 60 degrees of the type of movement I've inserted to take us up to outside measurement, and then back down. Okay, and then another 120 degrees around this back section. And I've done that the same for all of these. So the difference between the shapes is purely the difference between the different types of movement and how they interpolate the values I've inserted. So just bear that in mind. Just have a look back at this menu if you need to double check, if you're not familiar of, maybe the waveforms and what that would actually produce in the form of a cam. Okay. So the first section on this item, I'm going to show you the type of shape I'm looking to create. I'm looking to create this sort of shape of cam. So it should be fairly simplistic to set up. The first section will just be a short section of dwell for 90 degrees around this back section here. I'm going to start. Okay, so it will go from about sort of this point here around 90 degrees at that same 3 mil radius. So we'll select dwell, or we'll make sure we just go around to 90 degrees, which will keep us at that starting radius just first of all. Then what I'm going to do is just insert a section that takes me around over an ending radius value to a slightly larger value than what we've got inserted there, over degrees of motion of 120 degrees there. So that will take me around from this section up to about here, okay, for that back edge. So that's going to take me on a constant acceleration. I'm going to put that value at about 10, and the degrees of motion I'm inserting there, I'm going to put in 120 degrees of motion in there. Okay. Now if I'm actually inserting 10 in here, that's going to mean I'm going to need to increase the starting radius actually. So I will slightly increase these values. I'll put this one to 6, which will make it all a little bit bigger, and then this one I'm going to put to 2. Okay, and that will just slightly increase the value we start from. Then I'm going to go around this top section. I'll take myself down to about here, which is slightly lower than the starting radius. That will take me around about 60 degrees. Okay, so degrees of motion to 60, and I want to end the radius at 5, slightly lower than what we started on. And then what I'm going to do is I'm going to go for a modified sine. Okay, and that's just going to take me around that top section here. The figures for this, well, I'm going to go slightly higher than what we had to start off with. And degrees of motion, well, I'm going to go for 45 degrees. Because you'll see we've got to end up at 360. So we've then got 45 degrees left to put in to actually complete the loop. So the last section is just taking us back to the starting radius again. So we'll put in that last little figure. I'll put in a harmonic, and I'm going to go around to 6 for the ending radius, and again at 45 degrees, and that takes us to 360 degrees closed loop because we started at the same figure we ended at, okay, on a circular item. That's obviously very important. Then we end up on the creation tab, and the creation tab is actually where we put in the figures for the overall shape of the item. So if I just switch back to the PowerPoint, we can see here's the figures that actually we need to insert within here. Now we've got the near hub diameter, the blank chamfer and fillet measurements you can insert there. They're relatively simplistic values. You don't really need to insert those. You can put in a far hub diameter as well as a length. But the most important measurements you'll find when you're actually inserting your cam is the blank outside thickness and the blank outside diameter. Okay, this would be the actual values for a revolve feature which creates the cam. So just bear in mind, you know, if you need to check what each one is, just again switch back to this screen so you can check, and you can even make sure you're getting the right values in there depending on the type of cam you're looking to create. So the blank outside diameter I'm going to put in is going to be 20. Okay, and the thickness of this item, well, I'm going to go to a 10 mil thickness. The near hub on this design, well, I'm going to take that very small measurement. Again, that's going to go to 4, and I'm going to take that over 0.5. Okay, so it won't be particularly thick on there. The blank fillet radius and chamfer, well, I'm not going to put in a blank fillet radius or chamfer value. That will just chamfer some of the edges. I don't really want them chamfering on there, so you can actually leave those values blank. The through hole diameter, that's the hole through the center. So what we can do is we can insert a value. It's got to be obviously slightly smaller than what we've inserted here. So I'm going to go for 2 in there. Okay, and that should make it large enough. Then the values down here for the track type and depth, well, we've got it set to blind at the moment. We can put it to through if we want to. That will cut away the design. So if we're putting in and we're selecting the inner section, we can go for inner or outer. It selects the different areas of the cam, or we can go for both. If we're inserting just the inner section, and that's what the part we're actually choosing to create, we can choose to either do a blind cut to cut away the outside area of 2.5, or we can go all the way through the design, okay, to cut away that area completely. I'm going to go blind dimension. I'm going to cut back into the design by 5, okay, and that should give me enough sort of space there. Okay, once you've actually put in all the dimensions, you've made sure they're correct, we need to obviously double check that our outside diameter is large enough for the radius values we put in here, okay, and the follow diameter values we've got there. We can then click the create button, and that should run through and actually create our cam. Okay, now what you'll notice is it's actually created it with a lot of small faces in there. If you don't want it to be created in that way, you can actually switch the resolution type in there. You can change it to angular increment instead and click the create button, and that again will just run around and it will create it slightly larger increments around 360 degrees there. So I'll just move this menu out of the way. You can see it a little bit clearer. There we go. So that gives us a bit of a smoother path, not quite so many fragmented elements in there. But it depends on whether you want the thing very accurate or whether you want it to actually be easier to use there. Okay. Once we're done with this menu, we just click the done button. Then we can go ahead and actually save this model. Well, I'm going to save it and then come back to it later on. We're going to create an assembly from it very quickly. So I'll just save it within my Cams and Grooves menu. I'll just click save on there, and then we'll just go ahead and have a look at the other type of cam first of all. So if I click the toolbox menu, have a look at cams again. This time I'm going to create a linear cam. Okay, now the linear cam is fairly straightforward. We've got the follower type again, whether it's translating, whether it's slightly inclined by a dimensional value, or whether it's swinging. Okay, I'll put it to translating, and we're going to go ahead and put in the follower diameter of 1. Okay, the starting rise is how far up we're starting from this bottom edge. So I'm going to put in a value for the starting rise on this one of 2. The starting run is how far in we're starting from the left or the right hand edge, depending on which way you're starting at. The starting run I'm going to put to 1 as well. Okay, and then with cam motion, we can either go left or we can go right. Okay, I'm going to put it to left. So that means we're starting at this side and then creating in this direction. So that's set up the cam in terms of properties. We can then go to the motion tab and we can go ahead and start inserting the movements. Now for this one I've shown you, again, this is the movement I'm looking to create for the linear cam. For this one we've got the same type of movement interpolations between different areas, but the most important values are actually how high you're climbing and how far you're doing that movement over. Okay, so just switch back to SolidWorks now. So the first part of movement I want to put in, if you saw that little picture, we had a dwell, and that dwell just took us over a small value of 2 millimeters. I'm keeping this item fairly small, and then we're going to rise up that steep path there up to about here. Okay, and that will take us, if I put in maybe a constant acceleration there, like say the different types of movement don't matter too much, it's actually the values you put in here. So the ending rise for this one, that's going to take me up to about 8, and the run distance for this one is over 7. Okay, so that takes me over 7 for the value across the bottom and 8 for the height. Then we'll just dwell across the top, so that keeps us at the same value for a little while. Okay, and we'll run that over a distance of 4. And you'll see the total motion just topping up all the time. Then what I'm going to do is bring the thing back down again. So it's going to come down to a figure of 6. So I'm going to put in a constant acceleration in there. Okay, the ending rise for this one will end up at 6, so it's slightly lower than what we had there, over a distance of around 3. Okay, then we just got to have another dwell across this short section here. So I'm going to add in that dwell figure, okay, and that's going to take me over 4. And then we just got to have that small flick on the end there. Okay, in order to insert that, we first of all need to come down very slightly. So I'm going to select a modified trapezoid. I'm going to put in an ending figure of 4 over a distance of 4, so that takes us down to 4 for a distance, and then I'll take us back up again with that modified trapezoid again, back to 6 again over a distance of 4. So that takes us up to 28. And you've got to include the starting run, so we need to make sure that our width of the object is at least 29. And if I go to the Creation tab, well, that's the first thing we need to insert. We go to insert the blank length there. That's our figure. That's got to be at least 30 in here, but that's obviously at least enough for our dimensions. The blank width, well, that's the actual dimension across this side here. We're going to make that 10 because we're going up to at least 8, and the blank thickness of this value, well, I'm going to go in here, I'm going to make sure the value of the thickness is at least 5. Okay, we can then cut back into the design. I'm going to cut all the way through the model, and I'm going to make sure I've got the upper and lower sections. Okay, so I'll put in both there. The motion increment, again, if you make that too small, it's going to make a lot of very short lines in there, so I'm cut that at 1 there. That works fairly well for this design. Okay, if I click the Create button, that should create my cam. That's created it quite nicely. You can see that matches up with the picture fairly well. Okay, so that would be how you'd actually create that kind of shape within SolidWorks. So what I'll do now, just to finish off the webinar, is just show you maybe how you'd mate up a cam within an animation or something like that. So for this item I've created earlier on, I'm going to go ahead and make an assembly from it. Okay, I'll insert it within the assembly, and I need to make sure that obviously it's not fixed. So I'm going to get rid of these mates that it's already got. It's fixed in place. So I'll float it, and then I'll show the temporary axes in order to make it in place, the axis that runs through the middle. And I can use that temporary axis then to position it. I'll position it relative to the front plane. Okay, and also I'll position that temporary axis so it's positioned on the right plane as well, which is a little bit out of view there. Okay, to make sure the back face doesn't move, I'm just going to make that back face onto the top plane there. That nicely makes the thing in place. And then if we hit the tick, with those three mates, we should find the item will rotate quite nicely. Okay. Then what we can do is we can go ahead and insert the next item within this design. So I'm going to click Browse. I'm going to insert the follower, which I've already created in here. It's a little sub-assembly. Okay. In order to insert this one in place, I'm going to take this and I'm going to line it onto the top plane. Okay, on the front plane rather. The back face of the design, I need to make it sure it's lining up nicely with this face just here. Okay, in order to make sure it stays level, this bottom face, I'm going to make sure it's parallel with the top plane, or the front plane rather. And then the final mate is that cam mate. Now one thing to bear in mind here, to insert the cam mate, we select it from the mechanical mate section. You need to make sure that all of these faces are tangent, so you'd either have to go into the design and insert some little fillets between the areas, because you'll probably find if I show you now, if I select all the way around on this cam, it probably give me a little bit of an error when I actually try and select the cam follower there. Okay. If you hit the tick, it will probably give me an issue. There we go. It needs to be continuous. So one way to get around that issue, if we just cancel out the menu for a second and switch back to the part model, okay, is to actually just make some small changes if we just edit this sketch. Okay, if I go in here and I just insert a fit spline around these sections, I can make sure it is a continuous loop. Okay, we can go in ahead and hit the tick on that one, and that will create one face rather than several. It just makes it that bit easier when you go ahead and actually put it into the assembly model. Then you can go ahead and actually make this thing in place with that face using the cam mate with your follower, and you find that that nicely just makes it in place quite well. So if you rotate the item round, you'll see that it nicely just follows the shape of my cam there. Okay, so hopefully that gives you a good idea of the grooves tool and the cams tool in SolidWorks. Like I say, they're fairly useful tools just for slightly automating the process of some of the items that maybe you wouldn't have to create every day, wouldn't want to have to create every day. You might come across quite often. With the cams tool, it's obviously got quite a lot more in terms of actually what you can create from it. But hopefully the sort of menu systems that I've shown you will make it a little bit easier to use. Okay, thanks very much for watching.